Okay, so now we're going to finish up the section 115 in Algebra 2, and this is dealing with linear inequalities for shading graphs. And the first part was just dealing with linear um, equalities, so showing that. So here's our equation. So you'll notice on our equation that if I were to graph this, because I have the x and the y on the same side, it's probably easier to use intercepts, because if I plug a 0 in for x, which means I'm finding my y-intercept, then y equals -2, because I'd be dividing both sides by -4. And if I plug in a 0 here, then I would have x is 8/3. So 8/3 is approximately, well, not approximately, but it's 2 2/3. So the x-intercept would be 2 2/3, which would be somewhere like around here. And the y-intercept would be right down here. So let's go ahead and show the line, hopefully. So I haven't done it. You can use the sketch to explore. So I have a point here at -2. I wonder if I can do that. So I don't want to do that. Erase shading. So, okay. So I probably should have done this first and seen how to do it. But I know how the line's going to look. It's going to look like this. And it's going to be less than 8. But I have to figure out 0, 0. You'll notice that that is, so I'm going to actually shade on this side of the equation. So I'm not sure where I'm supposed to go. Maybe I'm supposed to just go to the next one. Okay, never mind. So I'm going to hide it. Okay, so I'm not sure how to use that. You can use a sketch to explore. Let's see if I can figure this out. I figured out how to graph on the other ones. I haven't figured out how to graph on this one yet. So I'll show you how to do that later on. Oh, maybe that's what I'm supposed to do on the next one. Oh, move point P, the inequality symbol changes. So if I move point P around, oh, there we go. So there. Okay, and I can move it around over here. I'm not sure how that's helping me. But anyway, we're going to go through the next one, and it'll make more sense on the next part. So just skip over that. Don't worry about it. So graphing linear equalities in two variables. So again, it's an x and a y variable. I'm going to show you how to do it. I know how to graph things on there, so I'm going to do that. So we're going to go ahead and watch the video, and then we will come back and actually do this. So let's see how to. Okay, here we go.
To graph a linear inequality in two variables, begin by graphing the boundary.
That means to graph the line. So pretend there's an equal sign there and actually graph it as a line. So notice they're doing the y-intercept and they're doing the slope.
Use a solid line for an inequality that includes a less than or equal to or a greater than or equal to symbol. Use a dashed line for an inequality that includes a less than or a greater than symbol. Next, use a test point to determine which half plane should be shaded. Selecting 0, 0 as a test point often makes calculations easier. Then, shade the half plane that contains the solution set. If the test point makes the inequality true, shade the half plane that contains the test point. If the test point makes the inequality false, shade the other half plane. To check your solution, identify a point in the solution region. Substitute its coordinates into the inequality to check that it makes the inequality true.
So checking the solution is okay, but if you did 0, 0 and you were diligent in making sure everything was good, of course I would accept that as well. So that would be okay to do that one also. Okay, so can a linear inequality ever be a function? Yes, because if I do the vertical line, oh no, it can't be, because if I do a vertical line test, all these points here in this part right here would be part of the solution, and there's too many points here. So a linear inequality cannot be a solution. It doesn't matter which side it's on. Okay, let's move on to the next one. We're going to start doing some graphing. We're going to do an open half plane. An open half plane means that it is not going to be equal to. So notice it's not equal to. And of course, they give us some crazy numbers there. So we are going to move things over. So to do that, negative 3.5 minus 7 greater than 10.5. So I'm going to kind of show you how to do this, and we're going to keep the y on the left side. So, and I can already see some things that are going to happen. So negative, as soon as I get it to go, I'm going to turn it off and turn it back on. Just isn't responding. Hang on. Okay, there we go. Now it's responding. Okay, so negative 3.5. And notice computers are wonderful. So if you ever thought that computers are going to take over the world, you can obviously see that's not happening yet. So y minus 7 greater than 10.5. Okay, so now what I need to do is I need to solve for y. And so when I'm solving for y, I'm just going to check the equation one more time. So when I'm solving for y, I need to pretend there's an equal sign there. I'm just going to do the same steps. I'm going to add 7 to both sides to isolate the y. So I have negative 3.5y is greater than 10.5x plus 7. And then I'm going to divide both sides by negative 3.5. So when I divide, remember, if I multiply or divide, I multiply or divide by everything. If I add or subtract, which I did in the first one, I only added to the two sides. So those are going to cancel. So I have y. When I divide or multiply by a negative, that causes the sign to change direction. Only when I'm multiplying or dividing by a negative. When I'm adding or subtracting, it doesn't change ever. So now in this case, that actually turns out to be 3x. And then, of course, we have minus 2, and that should be negative 3. So we have this equation. Now notice it's an equation. It is an open dashed line because it doesn't have an equal sign. My slope is negative 3, and my b is negative 2. So my slope is negative 3. So y is less than negative 3 plus 2. Uh-oh, what did I miss? Oh, plus negative 2. And I had a negative 2 there. That's my fault. So I have to be careful, right? I said negative 2 and I wrote 2. So I know you do this, and this is why it's so important to make sure that you are always showing your work so I can see that when it pops up. So now what I have to do is I have to find the equation. So it's less than, it's a dashed line, so it can only be b or d. The slope is negative 3. Well, we'll look at negative 2. That one goes through negative 2. That one goes through negative 2, so that doesn't help me. And then we go negative 3. So these are the same lines. You can see that. So if I come from this point right here, I go down 3 over 1. I go to this point. I go down 3 over 1. Unfortunately, it's still B or D based on that information. Now I have to figure out, does 0, 0 work? So we're going to plug in 0, 0 into the equation and see what happens. So 0 is less than 0 minus 2 because I plugged in 0, 0. Okay, so I'm plugging in this point, 0, 0. And then I get 0 is less than negative 2. Is that true or false? So is 0 less than negative 2? No, so it is false. That means 0, 0 is not a point. So 0, 0 is not a point, so it has to be D. Okay, so now we can check our answer, and we got it right. So I was a little bit more careful this time, and we figured that one out. So now we're going to do one last graphing with a closed half plane. So that means it's going to be a solid line. And how do I know it's a solid line? Because it says closed, but I also can see that it's solid because of that equal sign. So negative 12x, 3y, and 6. Negative 12x, 3y, and 6. So negative 12x, 3y, and 6. And I can't remember. I think it's greater than or equal to. Negative 12x plus 3y greater than or equal to 6. Okay, so now let's go ahead and solve for that one. And since I started on a different page, I'm going to have to do it here. So I am going to add 12x to both sides because I have to get rid of the whole thing because I'm isolating that one. So I get rid of the whole thing by adding it to both sides. Of course, these cancel. Greater than or equal to, I'm adding. It doesn't matter. It doesn't change signs. Dividing everything by 3. Because it's positive, it doesn't change the signs. So y is greater than or equal to 4x plus 2. So this time it is 4. So greater than or equal to 4x plus 2. Greater than or equal to 4x. And this time they're positive. So check my answer, and everything's okay. So now we take a look at this. So now it's easy. I see my slope. I see 2. I see greater than or equal to. It has to be a solid line. So it has to be either B or D again. And then this time I can see, if you look at the line, the exact same line, just shaded differently on the 2 sides. So now I have to plug in a value. So if I plug in 0, 0, so I plug in 0, 0, I get 0 is greater than or equal to 0 plus 2. So 0 is greater than or equal to 2. Is that true or false? Of course, 0 is not, so therefore it's false. So it's false again. So 0, 0 is not part of the point. So then notice here, this one is not. So therefore it's going to be B. Check my answer. Got it right. And now we're set to go on to the check. And that's the end of this video and the end of this section.